Alrighty. Let me open up 1.6 daily problem. Gianna, thank you for emailing me about number 1 and 2. So that's what I want, guys. If you are doing problems and you're like, oh, I don't know how to do this, then just shoot me an email. I will go ahead and record this and email it to you. I mean, we can always do like a Zoom appointment, but if you and I cannot find a time that meets both of our schedule, I can always record something and post something on YouTube and then just send you the link. I did do number 3. And then I think I did make an announcement with the link to this video, so you can look at that. But if anybody needs number 4, just let me know. Here's number 1 and 2. So H. If the graph of the function h is defined by this, h of x equals x plus 1 squared, and then we got that minus 4 outside. What does this minus 4 do? What does this do to the graph? This graph was shifted down 4 units from the origin. Right, the vertex is. And looking at this plus 1 inside, what did that do? This adding 1 inside and shifted the graph left 1. Okay, so that's what's happening. So this h of x is not at the origin. It's down 4, left 1. That's where its vertex is. If I plot it, just I want to see, down 4 over 1 to the left. Here is the here's the vertex of h of x, and I'm not going to sketch it because this problem, they don't want you to graph h of x, but it's going to look something like that. That's going to be your h. But I'm not graphing that. But now let's see. It says this graph is translated vertically upward by 2 units. The first thing what we're going to do is we're going to move it up by 2 units. And then horizontally 3 units to the right. And it becomes the graph of function g of x. We can do this graphically, but I think I'm going to go ahead and do the method that I did in class so that it kind of reinforces what we did. It's seeing similar things. So here's g of x. G of x is moving this h of x, the original h of x. So guys, if you take a look, I wrote down h of x, but we're moving this graph 3 units to the right, right? We're moving this graph 3 units to the right. So what are we going to do? We're going to subtract 3 inside. And do you know what I mean by inside? Like inside of this parenthesis that's getting squared. So subtract 3 inside. And then next, vertically upward by 2 units. Add 2 outside. Okay? If I do plus 2 outside, I mean, we wrote down what g of x is. We just need to simplify it. So let me go ahead and simplify this. G of x equals x. Take a look. What do we have here? If you add 1 minus 3, 1 plus negative 3, or what that is, it's going to be x minus 2 squared. And then if I combine these like numbers outside, negative 4 plus 2, that's going to give me negative 2. So I got the expression for g of x. What else you can do? Take a look. Remember this point that I plotted? This is the vertex of the original function, h of x, right? This is the vertex of h of x. They did say they're moving this guy up 2 units. Up 2. And they also said they're moving this 3 to the right, right? 1, 2, 3 to the right. Right 3. So the new vertex, the new function, g's vertex will be right there. The new vertex, this is the vertex of g of x. Okay, and that kind of matches what we got, right? Because the new equation that we just wrote has a vertical translation of down 2. That is down 2, right? Subtracting 2, outside is down 2. What else? We also have inside, if you take a look, that one is subtracting 2. So subtracting inside, that's going to be moving it right 2 units. And is that what's happening? If I go right 2, down 2, yeah, I'm right there. So, I mean, you can check it. You can do it different ways. You can do it graphically. You can move the vertex and write the equation. Or you can just add or subtract to the original given equation and you can simplify it. It's up to you. But now I want to plot g of x. I'm trying to graph g by plotting at least 3 points. Let me go ahead and minimize this a little bit or make it a little bit smaller. Is that too small? But I know you were writing down these with me as I was doing it, so you'll be all right. All right, let's go ahead and find some points to plot. Now, let me erase these ones. I don't need them anymore. The only point that I know that is on g of x is that vertex right there. In fact, in section 2.1, chapter 2.1, that's when we actually go into more parabola quadratic functions. So, and then in that unit, I'll teach you how to graph a parabola using the axis of symmetry. But for right now, how did we graph? We graphed functions by plotting points. So if you want to do that, I think that's a great idea. So let me go ahead and plot some x and y values. Find some x, y values. So the vertex is at 2. Vertex is at 2. So I'm going to plot one point that is bigger than 2 and one point that is smaller than 2. So I'm going to go ahead and plug in x equals 1, 2, and 3 into this equation. And y equals x minus 2 squared minus 2. So I'm just going to plug in and evaluate, okay? So that's going to be parenthesis 1 minus 2 squared minus 2. 1 minus 2 is negative 1. Negative 1 squared is 1. And 1 minus 2 is negative 1. So I'm going to plot 1 comma negative 1. Okay, 1 to the right, down 1. Here's my point. I want to use, well, I'll wait. I'll go ahead and do this table method because graphing parabola, we'll spend some time together in chapter 2, but we're right now in chapter 1, so I'm just going to go ahead and do it the basic way, plotting points. So if I plug in 2, I know what is going to come out. It's going to come out to be 2, negative 2, right? If I plug in 2, the y value is negative 2. But let's see if that is correct. If I plug in 2, 2 minus 2 squared minus 2, that's equal to 0 squared minus 2. That's 0 minus 2. That is negative 2. So we should have a point at 2, negative 2, and we do have that. That's good. Next one, if I plug in 3 into the equation, that's going to be 1 squared minus 2. Which is 1 minus 2, and that is negative 1. And did you notice that this is on the same, the horizontal line as that point, like on the left. So, I still want to talk about the axis of symmetry. I'll do it right now. So I'm going to go ahead and just draw a beautiful parabola right here. But take a look. What's going to happen is that, well, we'll talk about the axis of symmetry, that this parabola is symmetric with respect to this line, x equals 2. So if I have a point right here, that is 1 to the right of the line, then I know that I'm going to have another point right here, 1 to the left of that line. So another point is going to be, let me go ahead and plot another point that is on this graph. I can go 2 to the right from the vertex. Listen, I can go 2 to the right from the vertex. But if you square 2, what do you get? If you square 2, 2 squared is 4, right? So you go 2 to the right of 4. 1, 2, 3, 4. You should have a point right here. So if I have a point right there, which is 2 away from the line of axis of symmetry, I should have another point that is 2 to the left of that line. So I'm gonna have a point at 0, 2. But this, what I was just doing with you just now, graphing this parabola using this axis of symmetry, is what I really need to go over in 2.1. So don't worry about it. If plotting point method works for graphing, that is all you need to do. I just needed you to plot 3 points, and I got 5 points. But I think that's enough for number 1 and 2. I just used plotting point method for here. But I'm show you real quick. So that's it for daily problem number 1 and 2. But I don't know if you checked it out already. What's that? Where did it go? Not exam 1. I think that one is not published just yet. But I did post the practice test. I have number 1, 2, 3, 4, 5. And if you look, number 5 is similar to what I just went over with you. Number 5 is starting with the graph f of x, you're moving this function down 5, 2 to the left, and then get a new function called g and graphing that function. So after watching this video, try this number 5. If we have time, if you have more time after finishing 1.7 and 1.8 this Thursday, we will definitely go over any questions that you have on this practice test, or we'll just pick problems on this practice test. And I did say I'll come back and add a couple more problems to this practice test later. Start with the 6 problems above. Exam 1 is usually like 12 to 14 problems. I'm giving you about half of them right now. I didn't give you the rest of it because I wanted to give you something by 3 o'clock today. So this is posted on Canvas for you if you want to start working on or studying for the exam. But don't forget to please sign up for your exam using this exam 1 sign up genius. And I see that you guys are doing it. This is awesome. Many of you signed up for, well, 4 of you signed up for Thursday. So that's great. Alrighty, but if you need anything else, any questions, just feel free to email me. I will record something and